Hi, everyone. It's Judy Warner. Welcome back to the On Track podcast. Today we have my friend Jim Brown of Green Source Fabrication. And we're going to talk about the micro via reliability issue that so many people have been struggling with. And Green Source has made great strides in this direction. And I can't wait to share them with you. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's On Track podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media.
Collaboration is critical to success. With us working remotely, it's more important than ever to convey design intent, review and comment, and iterate on mechanical, electrical, and software design features to get the perfect balance of user experience and form, all while improving manufacturing performance and yields. Working from anywhere and connecting with anyone has to be made easier. So at Altium, we're meeting the challenge head on. Right now, On Track podcast listeners have an exclusive, significant discount on Altium Designer with Altium 365 subscription. And to make this even easier, we're offering extended interest-free payment terms and a $400 bonus if you refer a collaborator so they get this deal too. So click the link below in the show notes to get your discount code now.
Well, hi, Jim. Welcome. So glad you could join us today and look forward to this conversation.
Thanks, Judy. It's good to be here. Thank you for hosting us.
My pleasure. Well, I love your background. That looks like the pictures I've seen of Green Source.
Yep. Behind me over my right shoulder, your left is our electrolysis line, and the other side of the aisle is our whole treatment line, the permanganate and prep line for holes prior to plating.
It's a beautiful factory, and I always tell the design engineers that listen to us that, go see a board shop, right? So it's kind of fun for that background to see a little bit of the process. So thanks for that background. Well, Jim,
Yep.
Why don't you start out by just introducing yourself, tell us a little bit about your background, and then tell us a little bit about Green Source Fabrication.
Sure. Jim Brown. I'm the strategic account manager here at Green Source Fabrication. Been with Green Source for about 3 years now. Started in the industry in the early 90s in a very small board shop. Moved around a little bit, ended up at Hadco in the late 90s when we were really booming. From Hadco, they of course got acquired by Sanmina. And I left there in 2014, went to work for Park Electrochemical, which your viewers may know as Nelco. And then I left there and joined Green Source, again, just about 3 years ago.
Yeah, Green Source. So tell us a little bit about Green Source, because I've sort of been following the news and reading about you guys for the last few years. In the iConnect 007 magazine. So just give the listeners a little glimpse of what makes Green Source unique.
Sure. And it has been very good of the PCB 007 group to follow us. I think they've probably written maybe half a dozen articles on us, and they have followed us excitedly so. Happy and that whole crew have written a number of articles about Green Source. We started out about 5.5 years ago as a captive board shop for a company called Whelan Engineering. Whelan Engineering is a world leader in what is known as the mass emergency notification market. So they basically make a series of strobe lights and sirens So the easiest thing to relate to is police and fire. And they have a culture of wanting to vertically integrate all of their major components to be able to preserve and assure quality of their product. And the last thing that they brought into the family, so to speak, is the printed circuit board operation. So they connected with Alex Stupinski, who is our vice president and chief technical officer. And Alex put a plan together for them to be able to build their own printed circuit boards on the campus in Charlestown, New Hampshire. And just about 3 years ago, the decision was made to sort of separate us into our own entity and become an open market supplier to printed circuit boards. So we went into what we now refer to as phase 2. So phase 1 was the operation coming online to be able to support Whelen Engineering. Phase 2 is us coming into this open market and becoming the first printed circuit board fabricator to break ground in some 35 years.
And how many hundreds of people does it take to run GreenSource? She said, tongue-in-cheek.
Less than 100. It is, and that's a great lead-in, Judy. It is an automated shop, and that was the intent when we put the whole plan for phase 2 together. There were two things that became overriding in what that phase 2 operation was going to look like. Number one was make it as automated as possible, because the printed circuit board business itself is inherently very, very labor intensive. And the more people touch something, the higher the propensity for something to happen. So it becomes a yield issue because the machine is going to do the same thing every single time. The second factor that came into play is just about, I'm going to say 10 years ago, maybe a little more than 10 years ago, as the industry started getting more and more familiar with microvias and deploying that technology in high density interconnects, they started stacking them. And a unique mechanism of failure was discovered when we started stacking microvias. And we started looking at that failure mechanism and looking at the contributing factors to it. So the two things that came into play as we were selecting equipment and chemistry was, one, the automation, to be as highly automated as possible so we can be consistent. And number two was an eye towards looking at that microvia reliability challenge.
So that is a great segue, Jim. So for our listeners, why don't you sort of define that problem and that anomaly that was arising relative to stacked microvias?
Sure. It's a well-known issue, and it's been around again for 10, 12 years. Some of the early deployers of that technology discovered the phenomenon, and the folks at Motorola Solutions have been looking at it for in excess of 10 years. And essentially what is happening is at the base of the microvia, there's three separate interfaces. You have the target pad, the landing pad, interfacing with the electroless copper. Then you have the electroless copper interface with the flash. And then you have the final plate interface with that flash plate. So you have three different, let's call them lines of demarcation that will take place in this plating cycle. And as product starts to see thermal excursions, everything is going to start to expand. In the Z-axis is the one we are most concerned with. and copper has a different CTE than the surrounding laminate wood. So they're expanding at different rates. And what we have discovered is there will be some separation at one of those three interfaces, and it may not constitute itself in a failure immediately, which is even a bigger concern to OEMs because it becomes a latent defect and you can't contain it because you don't know it's there. So some of the work that's been done, and again, Motorola has probably been the biggest collector of data, is you can actually watch these microvias open up and close back up again. So they almost self-heal. So you have to be monitoring the resistance of that via through the entire temperature cycle in order to see that failure mechanism. And the more vias you stack, the greater the likelihood of that failure mechanism coming to reality.
So from what I've learned about this issue, Jim, is that, for example, you could do 2-3 stacked microvias on a dense HDI board, but it could go through traditional, testing, say at the board manufacturer, and it will pick nothing up. But then it goes through reflow, as the board gets soldered, and then they open up, and like you said, and then they self-heal after
Right.
the board cools down.
Yeah, exactly.
So,
that's the scary part.
That is the scary part. So it's intermittent, it's latent, and you never know when it's going to show up, which obviously is a big problem if you're Motorola or you're making a jet and
Right.
you don't know the environment, right? So as they heat up or cool down, this
Mhm.
can present itself in the field. So, so you mentioned those 3 areas that, in regards to plating that happen. So what kind of challenges does this present to you as a fabricator?
Well, as fabricators, one of the things that we are doing is, by and large, these are laser drilled vias. There are a few companies out there that are still doing mechanical drilled microvias, but by and large, laser is typically the method that everybody uses. So it's a much smaller hole, and the laser itself is imparting a tremendous amount of energy into a confined area. So we're disrupting, if you will, both the copper as well as the laminate. So that phenomenon, if you will, has been dubbed the heat affected zone, or HAZ. And again, IPC has done a lot of work on this as well. There's papers out there, there's presentations that discuss these phenomenons. So you have to control how much thermal trauma you're exerting onto the different materials, and then you have to control the plating. And it is a situation where if you don't get the first step right, it doesn't matter how good you do step 2, 3, 4, and 5, because you don't have a good foundation.
In regards to what you were saying about IPC, I know that I've seen articles, actually for our listeners, I'll throw a couple links below. Happy Holden, who you mentioned, has written an article for Altium, and I'll throw that in the show notes below so people can read about it. And he's really highly praised the work that GreenSource has done. But what is, you said that IPC's been working on this, or we've been working on it collectively.
Mm-hmm.
What are some of the things that IPC has done over the years to help address this issue?
Well, they've put a couple of consortiums together. They have a committee that addresses this specifically. And we have been attending their Microvia High Reliability Forum that they have hosted. That's been going on for at least 3 years now. And they're having it again this year, but this year it's going to be obviously virtual. And I believe it is sometime in July. We can look up a link for that as well, and you might want to put that at the bottom so that folks can go see that and register for it.
Yeah, I'm way ahead of you, Jim. So I looked it up just yesterday, and it is July 15th and 16th, and I am throwing that link in the show notes below. So if you'd like to attend, since it's virtual, it's pretty easy. It's like doing a webinar.
Right.
You can pop in and out. So, I really encourage anyone who's interested in this subject to join.
Yep.
Great minds think alike, Jim. So as you and I were preparing for the podcast, you said something that's really true and rather poignant, is to our listeners who are design engineers, they're like, yeah, blah, blah, blah. We don't care. Just make it go away. We could talk about plating and laser drills and all this, and they're like, I don't care. Just make sure it's reliable, and then prove it to me that it is reliable and that in my product, it's not going to have a problem in the field. So let's talk about sort of what sources of data is available to design engineers sort of post-process that's going to assure them they're not going to have intermittent failures or latent defects that are going to bite them later.
Yeah, and that's a great point, Judy, and you're right, because we can show up with PowerPoint presentations and we can have all kinds of, like Alice's Restaurant, right? We'll have 8x10 color glossy photos with pictures and arrows showing how wonderful our products are. But at the end of the day, the designer wants something in his hand that's going to do what he designed it to do. So how do we do that? We need data. And how do you collect the data? In this particular instance, we are, of course, talking about Microvia reliability. And the most reliable way to determine reliability is to do some sort of accelerated testing. And one of the defaults for years has been IST testing, which simplistically is inducing thermal stress onto the part by pumping current through it. And you just heat up the structure. And what typically happens is you take a resistance measurement of the feature, run it through the IST tester, take a measurement after it comes out of the IST tester, and if it's within the customer's predetermined envelope, you consider it good and it ships. One of the things that has been discovered with this particular mechanism of failure on Microvias is it only occurs at elevated temperature. So you can sit there and run a failed Microvia up and down, and testing it before, testing it after, it's going to look good because it almost performs like a thermal switch. When it gets hot, it opens up. When it cools down, it closes back up again, and you're not going to see that at ambient measurement. So you have to be able to monitor it through that thermal cycle. And again, the folks at Motorola designed their own tester to do that. And there is now another method on the market, in addition to IST, from a company called CAT, which is Conductive Analysis Technology. And they have a system called an OM tester, which monitors the resistance of the subject coupon as you're running it through the thermal cycle. And the typical parameter is you want to see less than a 5% change in resistance of these structures as they're being thermal cycled. So we have instituted that. We have a CAT tester on site in Charlestown in our facility, and we are routinely collecting data on these microvia structures, and we are doing it for two reasons. One is it helps make the customer feel comfortable. After all the PowerPoints and the pictures and the color glossy photos and all of the diatribes, you can hand them data and say, here's the data we've collected over the last 6 months, 12 months, whatever. And they can actually see, okay, so the pictures are true. Here's the physical evidence. IST, again, it's been tried and true. It's been used for years. And I don't know at this point that there is a feature with IST where you can monitor through the thermal cycle. The OM tester does do that. So we use it not only to help the customers feel comfortable, but we also use it for our own process improvement. So there is an IPC test method for the CAT ohm tester, and it calls out a less than 5% change through 6 thermal cycles. Internally at GreenSource, we have instituted 25 as our minimum. So that's the number of cycles we want to see. We have achieved that, and we're collecting data based on that. The IPC standard is 6. We obviously want to exceed 6, but like I said, we initially bought the CAT tester not so much for customers' benefit, but for our own, because for us, it's a continuous improvement tool. We can see whether or not our processes are continuing to yield consistent product. And we also use it in how can we take this data and do continuous improvement to maybe get to 30 cycles.
Makes sense. So you mentioned the IST and the OM tester. Over time, obviously you're using the OM tester, but as far as the IST goes, do you use one or both? And what does that data output look like? Like, where have you fallen as a company, the type of test that you prefer and the data output that will make customers feel comfortable?
It's a good question. And it's really, for me, I guess I would say the best thing is it's a personal preference thing. IST has been around for a long, long time. It's tried, it's true. Everybody knows it works. It works well. It does a great job. What's unique about this mechanism of failure that we're seeing with these microvias is it's essentially intermittent. And IST will find a thermally induced failure. It's not necessarily going to find a thermally induced intermittent. What the OM tester does is we're monitoring the resistance of the structure through the thermal cycle. And we can show you the data, and it is very interesting because we can show you data where you will see microvias that look good, and you start to increase the temperature, and you get up between 210 and 220 degrees C, and all of a sudden, pop, they open right up. And you can see them, and they stay open, and as you bring the temperature back down again, they get below 200, they get down below 180 C, and they, as we've coined it, self-heal. And the resistance comes right back to what you would conclude to be a normal value. So if you just did the before and after, you're going to have some escapes. And certainly we don't want that. And I believe OEMs don't want that either.
Definitely not. So at GreenSource, you use both types of method then?
Now, we have committed to the OM tester. Obviously, these pieces of equipment are not inexpensive. we think the OM tester is much more functional for finding this particular mechanism of failure. And that's the one we are most concerned with. So that's the investment we have made into an OM tester. We can do IST testing. We certainly will do IST testing if a customer requests it, but we will send that out.
Listening to you, I would say for our listeners, the takeaway would be follow the data, right? Don't follow the glossy PowerPoints.
Yeah, don't listen to the salespeople. Get the data.
Get the data.
Yeah.
Well, this has been a really interesting conversation, and I thank you so much for coming on. For our listeners, I interviewed Jim also for our June newsletter, and so I'll throw the link for that below as well. And he also shared with me some pictures of GreenSource, so you can see what an automated circuit board shop looks like, which to me is super exciting. It's not something we really have, particularly here in North America. And everyone knows if you get human hands off, the reliability goes up. So any concluding thoughts before I let you go?
I just to follow up on your comment, Judy, I've been here 3 years. I am no less excited about what GreenSource has today than I was 3 years ago when I walked in the door. It is a very impressive, state-of-the-art automated shop, and I'm blessed to be working here. I really am.
Yeah, well, one of these days we're going to get out and see ya, and we're going to film that shop and share it with our viewers and listeners. I also invite you, Jim, and also our listening audience to find our YouTube channel, which is the Altima Academy, because we put sort of tool agnostic educational content there, and that's where we would, eventually when they let us out of our homes again and we can fly, we'll come out to New Hampshire and take some footage there. I'll also share some links to articles that iConnect has done, and hats off to them for really finding you guys and Alex Stupinski and really highlighting how your technology is really good for the industry. So
yeah, they've been great. They have spent a fair amount of time in the shops, have interviewed, like you say, Alex a number of times. So they've done a real good job, and we're very grateful for the coverage that they've given us as well.
Well, I worked there for a short time, and I love them. Those are my people. So I'll make sure they did a really neat drone flyover of the entire line before your latest updates, I think. So I'll share that also in the show notes below. So Jim, thanks again. This has been a really interesting conversation. Thanks for sharing what you're learning.
Well, again, Judy, thanks for having us. We appreciate you hosting the interview.
Yeah, my pleasure. To our listeners, thanks so much for joining myself today and Jim Brown of GreenSource Fabrication. I hope you learned something great, which is follow the data. So thanks again for joining. Please remember to like, subscribe, and give your comments below so we know what you want to learn about. Thanks for joining. We'll see you next time. Until then, remember to stay healthy, stay safe, and always remember to stay on track.